Hey guys, welcome. This is chapter 8.1 through 8.3 review. And in this review, I'm going to go over 6 examples. And in the 6 examples, they are going to be similar to the 6 questions that you guys are going to get at the end. So for the examples, you don't have to write down the examples. The examples are more just to help you figure out the problems if you need reference. But if you do, then watch all the video, then do the questions. But the questions and examples are totally different in terms of what it is asking. Okay, so make sure that you look at the examples, but you do the questions. Okay, so for my first one, it says, how many sides does a regular polygon have if its central angle is 30 degrees? So we know that on the inside, each of the central angles are 30 degrees, but we aren't totally sure how many sides it has. But what we do know is that if we had a whole entire circle and divide it by the number of sides in general, that's how we get the central angle. So I'm going to write that down. I'm going to put central angle equals 360 degrees divided by the number of sides. So we're missing n, but we do have the central angle, which they gave us here. So what I'm going to do in math is what we call substitution. So I'm going to take that 30 degrees and substitute it for the central angle. So that's going to get substituted there. So 30 equals 360 divided by n. So now we're getting a little bit closer to figuring out n, because what we can do next is, if you take a look at the fraction on the right side, you can also make a fraction on the left side and then do something that we call cross multiplication, which we are now proficient at. So we have 30n on this side, and then it should equal to 360, and then divide by 30 so that we can get n by itself. And then when we take 360 divided by 30, our final answer is n equals to 12 sides. Okay, and then I'm gonna box my answer. So this is a 12-sided shape, which we also call a dodecagon. All right, example number 2 is to find the area of a hexagon. So usually this hexagon, we first cut our shape to triangles. We then find the central angle, find the area of that one triangle, and then we find the area of the whole entire hexagon. So let me just start off by cutting it into pieces. So if I were to cut it, it would look something like this. And then because we've done this so many times, we know that the central angle is going to be 60 degrees. And then I'm going to draw my triangle out so that I can be able to find the area of my triangle. And the triangle I am taking is the triangle with the height of 8 square root of 3. And I know this is my height, and I know my base is missing. So because my base is missing, the easiest way to approach this problem is just to pull out one side of this triangle and then focus in on just that one side so that we can figure out what the base is. Okay, and then we've done different types of problems that are similar to this with the base, the base there and the height missing. So just make sure that you know how to kind of do both ways. So 30 degrees is up there, therefore 60 degrees is here. We know what the height is. And just given the height, we can find the base or the bottom piece of that triangle. We can also find the hypotenuse. So this piece is 8, and to get my hypotenuse, I just got to multiply that by 2 to get me 16. So I'm going to highlight the piece that I know, which is this piece right here, which is 8 also here. But because this triangle got split in half, basically, the other side should also be 8. So if I were to add these two pieces together, I know my base is 16. Okay, so when I find the area of a hexagon, I know I have to find the area of a triangle first. So I'm going to put area of the triangle equals, and then base is 16. Height is 8 square root of 3. And then once I multiply, I know I have to divide this by 2. So let me just do this on the calculator. And if you guys need to do it step by step, you may do so. Okay, so I get 64 square root of 3, and that's the area of one triangle. but I know I have a total of 6 triangles, so I'm going to take that value and then multiply that by 6. So area of the hex equals 64 square root of 3 times 6, and then punch that in. And then 384 is my answer here. And then I get centimeters squared. So that's my final answer. So hopefully that's not too bad, just because we've done it several times. Let me move myself first. And that's my answer there. Okay, moving forward. The next one is to find the sum of interior angles of a 15gon. So the sum of interior angles is a specific formula. And hopefully you guys remember, maybe not, is 180 times n minus 2. So in this scenario, they gave us n, so we're just basically plugging it in. So I'm going to go 180 times 15 minus 2, which is technically 180 times 13, and then go to the calculator. So 180 times 13 is 2,340 degrees. So in this shape that's 15 sided, it has 15 angles. If I were to add up all the 15 angles together, it should equal to 2,340 degrees. Okay, example 4, if the sum of interior angles is 1,980, how many sides does the polygon have? So notice that the previous problem, what we did was we found the sum of interior angles given the amount of sides this polygon has, but what if we have to work backwards now? So we basically are given the sum of interior angles and now we have to find the sides. So we're just like basically working backwards. But again, I'm going to write out the formula because the formula is important. Sum of interior, I'm going to abbreviate angles, this is how you usually write angles, is equal to 180 times n minus 2. So the only piece of information I'm given is this value right here, which represents the sum of interior angles. So I'm going to take that value and I'm going to substitute. So I'm going to do 1,980 degrees is equal to 180 times n minus 2. Okay, so our goal from here is to solve for n, because we want to get n by itself because n represents the number of sides. So notice that 180 and n minus 2 is being multiplied together. There are two ways you can do this. You can either take the 180 and distribute into both of the values and solve like so, or you can just simply divide 180 on both sides and then go from there. So this cancels like so, and then I'm going to do 1,980 divided by 180, which gives me 11 equals, and then the parentheses can drop, so I just have n minus 2. So notice how simple this problem is getting as I'm doing this, because my last step is to add 2 on both sides, and this cancels, and my final answer is n equals to 13 sides. So this polygon has 13 sides. All right, example number 5, solve for the missing variable. So we kind of have a lot going on here, but know that we do have enough information to solve for this. So in general, what we see is that we see a large amount of angles in here, and there's so many going on, but it's totally okay. Because we know that all these angles are very specific and they add up to something. So like if you think about a triangle, there are 3 angles in the triangle and they equal to 180 degrees. If you had a rectangle, it equals to 360 degrees. But what if you had something like this that is 5-sided? So 1, 2, 3, 4, 5. They don't equal to each other, but we know we have 5 sides. So how do we know something that has 5 sides, what does it equal to? We do have a formula that can assist us with that, because we know the sum of interior angles is equal to 180 times n minus 2. So what I'm going to do is I'm going to write that out. 180 times n minus 2 is going to find the sum of interior angles. And that's crucial because we need to know what this number is, so we can know what all these angles, these purple angles equal to. So I'm going to do 180 times 5-sided minus 2 is going to equal to something. And then that's technically 180 times 3, which equals to 540. So I know if I add up all these purple angles, angle A, B, C, D, E, it should equal to 540. So that's what I'm going to do here. It's going to get a little crazy, but it's okay. So 80 plus x plus 40 plus 125 plus x plus 5 plus x plus 50, and it should equal, like I said again, to 540. And if you want to write 540 in the middle, just so you know, that's my huge clue for you. Okay, so from here, combine like terms. I'll highlight all the terms so that I don't get confused. And then I have to do some calculations in my calculator in a bit. But all my x's, I have 3 x's. And then all my other values, 80 plus 40 plus 125 plus 5 plus 50. And I get plus 300 equals 540. Subtract 300 on both sides so that it can cancel. And then divide by 3. And then notice that this does turn out to be a pretty clean answer. So I do get, I believe no, it's not 60, it's 80, sorry. Okay, so in general, all my x values are 80 degrees. And if I were to, let's say, plug 80 degrees in there, I know angle A should equal to 120 degrees because 80 plus 40 is 120. All right, so that's that type of problem. And we are actually on to our last example, which is example 6. And then you guys will start your questions in a bit. All right, question number 6 is similar to last week's lesson, the last day of last week. But question 6 says, 2 quadrilaterals are similar. Quadrilaterals are like, let's say, squares or rectangles. And we have 2 of them. So one probably grew to become the other. The smaller has a perimeter of 20 centimeters and an area of 60 centimeters squared. If the perimeter of the larger quadrilateral is 40 centimeters, find the following. So we're going to find the ratio of sides. We're going to find the ratio of perimeters. We're going to find the ratio of areas. And then I will kind of re-explain what equals what, how you get one thing from the other. But let's just dissect this. So the smaller has a perimeter of 20 centimeters. So I'm going to write 20 centimeters here. And the area of 60 centimeters squared. And then, actually, let me move this over. Just kind of writing all over the place. Okay, and then the larger quadrilateral has a perimeter of 40 centimeters. Okay, so usually when we talk about ratios, we are talking about fractions. So maybe I'll just like draw a line right there and then I'll reduce my fraction. So notice that if I were to reduce this fraction, I can take out the 0. So I have 2/4, which turns into 1/2. So my ratio of sides when reduced all the way down is technically 1/2. So remember that usually the ratio of sides and the ratio of perimeters are equal to each other. So that means that my ratio of sides without even having any sides should also equal to 1/2. Okay, and then my ratio of areas, if I took either the ratio of sides or the ratio of perimeters and I squared it, then I know I will get my ratio of areas. So that should help a little bit with figuring out what the actual ratio is. So let's say, let me think. So let's say if I do this squared, then I will get that, for example. So let's say I'm going to do 1/2 and I square it. So notice I get 1/4. So ideally, my ratio of areas should be 1/4. But let's say I need to find what the area is in general to get to 1/4. So I know that if I did 1 times 60, I should get 60. So might as well do 4 times 60 to get whatever the area is. So 4 times 60 is 240 centimeters squared. So notice now I just found my area of my large figures just from figuring out what the ratio is. So this is my last problem for today. And then you'll see on the very next slides that you'll see question 1, question 2, question 3, 4, 5, and 6. So you guys are in charge of these 6 problems. Make sure you get them done, and then I will also show you guys the answers eventually so that you can make sure and check yourself if you did it right. But hopefully this video was comprehensive, and if you have questions, please ask me through Google Classroom.